All right, class, as we continue to work with roots, we're going to consider what happens in the context of an equation. Now, in this short video, I'm not going to put up word problems or anything of that nature. I really just want to focus on what happens when we end with something that looks like this. And you're going to see this a lot as you move into algebra and beyond. You'll be solving for a problem and you'll get down to this point right here and it'll say x squared is equal to 144. And the important thing to realize is that you are seldom, if ever, going to be solving for x squared. You're going to be solving for x. You want to know what x equals, not what x squared equals. So when you get to this point, you'll need to know how to solve. And this is where the square root function, if you will, operation comes back into play. So when we see that x squared, let's just focus on this side right here for just a moment. What if I have x squared and I take the square root of x squared? Well, that means it's x, right? Because x times x, and if we were to write the one exponent, which again we typically don't, we never do, but I want to illustrate it, when we multiply common bases, you remember this, we add the exponents. So x times x is x squared. So this is a perfect square. Its root is a single x. So what that means is that I can take the square root of x squared and solve for what I'm looking for right there, x. But you remember the golden rule of algebra. What I do to one side, here I've taken the square root of x squared, but to maintain equality and balance in the equation, I must do to the other side. So if I take the square root of the left side, I have to take the square root of the other side. And so I've got a lot going on here. I'm going to try to skip over to this right side. Let's just start over very briefly. X squared equals 144. And I'm going to take the square root of both sides. That gives me x is equal to 12. But there's one little catch here. And you need to go ahead and kind of put this in your brain. It's actually plus or minus. It's plus or minus 12. And this symbol right here, let me write it bigger up here so you can see it. That's what it looks like. And we'll say that's plus or minus. So you could also write it this way, x equals 12 or x equals negative 12. And we ask ourselves, why? Why do we do it that way? Why would negative 12 be a possibility? And here's the reason why. Imagine if I take negative 12 and I square it. Now again, this is going back. This is going from the root back to that perfect square of that radicand, that number under the radical. This one right here. I'm trying to go back to that. What's a negative times a negative? Well, it's a positive. Well, we already know this. 12 squared is going to be 144. And do you see right here? Whether I have a negative 12 or a positive 12, when I'm squaring them both, they're going to take me back to the same answer. And both of these are a positive 144. So when we're thinking about solving equations, and you'll be seeing more of this as you get into algebra, and you come down to something like an x squared equals anything, it's not always going to be a nice round, nice perfect square, but I can take the square root of both sides to solve for x or whatever variable they may give you. But this is important. You're going to see this a lot in algebra. Again, it's going to be a plus or a minus technically. Now, what about if it's a cubed root? What if we're taking x cubed? Like in this case, we have x cubed equals 8. Now, hopefully you know some of your cubic roots, your perfect cubes, and you'll know that the cubed root of this is 8. Well, the same theory, the same practice would apply here. If I have x cubed, I know what I'm wanting to have is x equals something. So if that's a cube, if x cubed, I'm going to take the cubed root. All right, now just as an aside, I think I've shown you this before in class. I can also write the cubed root of x cubed like this. That radical is replaced by this fractional exponent. Apply your power of power properties, and that becomes x, doesn't it? Because 3 times 1/3 is 1. All right, so when we take the cubed root, when the index matches this inside power, you're going to reduce it down to a 1 exponent, a single x. Now, what I do to one side, I have to do to the other. So I'm going to have x is equal to the cubed root of 8, and we know that the cube root of 8 is 2. Now it's not plus or minus 2, because think about it. If I said plus or minus 2, let's try it with the negative 2. That's a negative 2 times negative 2, which is 4. 4 times negative 2 is negative 8. That's not the same thing, okay? So when you're dealing with that odd index, it's simply going to be x equals 2 in this case, not the plus or minus that we saw over here. Let's just look at a couple more quick examples. So here we have the x squared equals 169. I would encourage you, if you haven't already done so, pause the video and try both of these before you continue and watch me do it. All right, so hopefully you've done that and you're back to hitting play. X squared equals 169. You already see I kind of started myself a little. We're going to take the square root of both sides. The square root of x squared is x, and 169 is also a perfect square. Now soon, I'm going to give you different numbers that are not perfect squares, and we're going to be simplifying those roots. But we know that that is 13. But wait, what did I forget? It is plus or minus 13, because we know that negative 13 squared is also 169. Now, what about the cube root of 27? Hopefully, again, you know some of your perfect cubes, and so you know that the answer to this is 3. But how do we do it algebraically? X cubed, we're going to take the cube root of this side, which means we have to take the cube root of the other side, and that becomes x equals 3. Not plus or minus in this case, because with that odd index, if we multiply a negative times a negative times a negative, our result will be negative. Guys, I hope this is a good review for you, working with square roots and some solving equations. We're going to do a lot more with this as the year progresses.